Okay guys, this is Miss Husmel and this is activity 2, so testing your servos. And so what I have here is my Arduino sketch. So you'll notice that I'm just testing the right servo right now. So I'm declaring it. You always have to include your servo library, which is the first line here, which includes servo H. And then I have to make sure that I always have my servo declared. So if I wanted to run both servos, I'd have two declaration statements here. But right now I'm just trying the right one. And then I'm going to try the left one. My right one is plugged into 12. My left one is plugged into 13. So I've already gone up to my tools here and made sure I have my board selected, and my port is the one that says, actually I have it disconnected at the moment, but the one that says Arduino is the port that you want. And then you just go ahead and upload it, and I'm going to show you what that looks like right now. Okay folks, so at this point I now have both my servos set up, my left and my right, and you'll notice that in my code what I have written here is that my servo right is declared, my servo left is declared, my right is at 12 and my left is at 13. This is the way it's written in the directions, and you'll notice that when I start it, that left one goes before it starts. I don't really care about that. It doesn't bother me. If it bothers you, then go ahead and move your left servo to like 11 instead of 13. And then it won't do that because it has to do a little power charge at 13 when it first starts up. Not a huge deal. If it bugs you, just move it to 11. And that means that your servo lefts would all be at 11. Notice that my directions are reversed because my motors are mirror images of each other. And that means that when the clockwise 1300 ones runs one clockwise and the other counterclockwise. So you have to figure out which direction. You should have the ball should be in the back of your robot, not the front. And so what you can see is that I'm running both servos for 3 seconds, stopping, going back for 3 seconds, and stopping again. So again, I just went into my tools, made sure that my board is set to Uno because that's what I have. And then I want the port that has Arduino on it. And then I should be able to compile and download this to my robot, and you should be able to see it run. Let's try that again here. There you go. That's the 3 seconds forward and back. Okay, folks, so this time I have both my motors programmed, my right and my left, so 12 and 13 on my bot. And I need to measure exactly how far it goes in 1 second, not 3 this time. So this is what my code looks like over here. I changed my delay from 1 second to, or from 3 seconds to 1 second, and I took out the part where it backed up because I don't care. The 1500 is where it should stop, and I need to know because when I go to do my maze, everything's done in centimeters. So for me to even get close to getting things to go far enough, I'm definitely going to need to know how far it goes in 1 second. So notice I do have it on my mat over here, but the problem is that my mat is in inches. So I'm going to go ahead and run it for you so you can see what happens. It will be in centimeters. I have my centimeter ruler here, and you'll notice that what I do is I pick it up, hit the button. There we go. So it went to, looks like 15.5 centimeters. So the reason I picked it up was because of that little 13. Here, let me show you what it does if I don't pick it up. See that little stutter? Yeah, and then it's just not straight, which is annoying. So, like I said, it doesn't really bother me all that much. So I'm just going to make sure that this I'm going to set it down right there so the center of the wheel starts at the 0 mark on my ruler and up. There you go. I did it again, and this time I got right at 16 centimeters. So let me do it a couple of times to make sure. Whoops, that was my bad. I set it down too late. So there's 16 centimeters. Okay, so it looks like my thing is 16 centimeters for 1 second. And so that should be able to get me some estimations later. So I'm definitely going to make sure and write that down in my notebook that it goes 16 centimeters in 1 second.